In class 12th, I will tell you about the sensitivity of potentiometer. I have told you about the potential gradient of the potentiometer, that is defined as the potential drop per unit length of the potentiometer wire, and it has the unit of volt per meter and Newton per coulomb, because this is equivalent to the electric field, delta V upon delta X. So sensitivity means the minimum potential difference that can be measured with more accuracy by the potentiometer. Sensitivity of potentiometer means the minimum potential difference that can be measured with more accuracy by potentiometer. Sensitivity of potentiometer means the minimum potential difference that can be measured with more accuracy by potentiometer. Minimum the potential difference, more is the sensitivity of the potentiometer. The sensitivity of potentiometer is related with the potential gradient of potentiometer. The reciprocal of potential gradients is equal to the sensitivity of potentiometer denoted by S. The reciprocal of potential gradient is equal to the sensitivity of potentiometer denoted by S. The sensitivity is denoted by the term S. So sensitivity equal to 1 upon potential gradient, and you know that this is X equal to 1 upon X. X the potential gradient, x equal to potential gradient. In some books, the potential gradient is written by K. So you have not to confuse that this is denoted by x here. The x does not mean the length, but this is simply the potential gradient, the potential drop per unit length of the potentiometer wire. So if you see the unit of S, now this is your meter per volt or MB minus 1, and one is coulomb per Newton or Cn minus 1, Newton per coulomb. This is just opposite to that of the coulomb per Newton, and C minus 1. And you can have that this potential gradient it is a scalar quantity. It is a scalar quantity, so it has no direction at all. Now the dependence of sensitivity, then what factors affect the sensitivity, or how can we increase the sensitivity of the potentiometer? We know that x equal to E naught upon L. E naught is what? The EMF of the cell in the primary circuit, and this x is equal to IR upon L. E naught equal to IR. So what we have here? This is the this is RH, this is now your K. Now its EMF is equal to E naught. This is now potentiometer by AB, and here we have jockey. This is E. Now that current passes through it. Now current is I here. So this is the main circuit. Main circuit. And the currents are the resistance of the potentiometer wire AB. So now if we use these terms, then sensitivity we can write the sensitivity S equal to, now this is equal to your L, and this is your E naught. L or S equal to L upon I into R equal to resistance of wire AB, L equal to length of wire AB, I the current. So you can see that the sensitivity can be increased by increasing the length of the potentiometer wire, and S can be increased by decreasing the current in the potentiometer wire. Thus, can be increased by two factors. Number one, by increasing the length L of potentiometer wire. Wire AB. Larger the length, larger the sensitivity. So this is why that we take a 10 meter long potentiometer wire. You can take more than this one, but that will be very hard to handle while we are doing the experiment. So S proportional to L. This is not so much. Second, by decreasing the current I. So S is proportional to 1 upon I. So the sensitivity can be increased by increasing the potentiometer length, by increasing the length of the potentiometer wire, and by decreasing the current I in the main circuit. Which is the current I by rheostat. By rheostat. This is not rheostat. So just you control the current, make it minimum so that the sensitivity is larger. So to measure the small potential difference, the gradient, the potential gradient must be minimum. So this is what the meaning of the sensitivity of the potentiometer and the factors that affect the sensitivity and how can we increase the sensitivity of the potentiometer. So thank you very much.